Good afternoon, everyone. So I'd like to take and introduce Grant McCormick, who is the GIS Enterprise Manager for University of Arizona, and he's going to introduce his team that's going to present Toto. I don't think we live in 2D anymore. Grant?
Thank you. So again, I'm the Enterprise GIS Manager at the University of Arizona, and we're going to be describing what we've been doing with 3D mapping today. And so let's see if I can get this gizmo to work here. So Toto, I don't think we're in 2D anymore. So we use this Wizard of Oz reference partly just to come up with a catchy title, but also because it kind of represents in general parlance now to mean that, if you remember the story, when Dorothy lands in Kansas, or she lands in Oz and she says to Toto, I don't think we're in Kansas anymore. It's sort of that thing about we're somewhere new, the environment has changed, and we need to kind of get our head wrapped around where we are today. And so that's kind of the idea with this is we're in 3D, it's a different thing than working in 2D. And so that's sort of why we are using this theme. And so we'll go ahead and proceed in here. In terms of the presentation, we have an introduction. We're going to talk a little bit about the frameworks that we've explored and where we are today with 3D data, applications and use cases, and also future directions. And I guess I hope I didn't. Yeah, I'll get to the other team member introductions in a minute, but I just wanted to give a little orientation of the U of A. So we're in Tucson, Arizona, and the university campus, main campus is about 490 acres, around 300 buildings on the main campus, 15.5 million gross square feet. The whole university has around 800 buildings statewide and about 18.5 million gross square feet. And this part of our Campus 360 map you can go to, and it shows the locations that we have around the state. There's a law college, a medical college, and it's an agriculture college with extension sites throughout the state. So there's a large presence throughout Arizona. And so I'll, at this point, introduce our team or have them introduce themselves. And so here are the characters. So maybe at the end, you could, in your evaluation, let us know which one of us you think each of these characters is. So.
Hello, my name is James Wadsworth. I am our GIS data analyst. I've been working at PDC since 2017 full-time. I started as a graduate student in 2015 where I was working on our sustainability web map, and I have moved into working with our 3D data a lot now.
I'm Mari Archuleta, the GIS analyst at PDC, and I've been there for about 2 years.
Hi, I am Naveed Ahmed, and I am GIS application developer at University of Arizona Planning, Design, and Construction Department, and I am with the group for the last 4 years.
Thanks. Okay. Again, so we're going to take you on this path down our red brick road instead of the yellow brick road. Since we have red brick on campus, we're going to say it's a red brick road. We're going to tell a story of our 3D work. So in terms of the frameworks explored, James is going to take this first section and give you a little bit of idea of what we've looked at. And first I want to just give a little orientation that we've been working on some facet of 3D for many years on campus. And what we're going to present is it's kind of in a way a basic framework. There's a lot of complexity behind parts of this. But our orientation has been to try and build a framework that's somewhat as future-proof as possible, that is adaptable to a lot of different use cases. So it's not just about interior wayfinding, not just about planning and massing, and not just about asset management, but actually can be adaptable in the future for a lot of different uses. And so we want to kind of give you an idea of that basic framework and what we have tested and where we're going. And so I think I'll let James then give you an idea of some of these frameworks we've looked at.
Thank you. So we're going to walk through three kind of primary frameworks that we've evaluated, and these are all Esri-based. I'm just going to put that out there. We haven't explored options with BIM yet or other software platforms. But we're going to start by looking at if you only have 2D feature class-based data, and then what you can do if you have that and maybe a little bit of LiDAR, and then converting that into true 3D geometry and multi-patch features, and then just a brief touch on how we actually collect and visualize some of the 3D stuff that's on our campus. So if all you have is 2D features, you can generate an image like this for kind of campus-wide visualizations. You can symbolize it based on the building uses if that's in your attributes. And the way that we've done this is we have a number of floors attribute in our data. And in ArcGIS Pro, you can create an extrusion expression in a 3D scene. And all you do is you multiply the number of floors by some average floor height value. So in this case, it was 12 feet. And it will automatically extrude these buildings to a rough approximation of what, what your buildings actually look like in 3D. Another method that you can use is to leverage Esri's solutions. So this image was created using Esri's 3D base maps for local government solution, and it required building footprints and LiDAR at the most basic level. This is the second level of detail. It had some roof form polygons in there as well. And the only requirement for your LiDAR data is that it's at least 3-meter resolution. And it's a task-based project that you can open in ArcGIS Pro and work through the steps, and it'll spit out this true 3D geometry. So that will persist if you open it in a different project. It'll still be in 3D. You don't have to redo the extrusion setting like you would with just 2D data. And then our third kind of framework is building on both of these a little bit, in that we have now floor-level detailed floor plates. So each floor has a ceiling and a floor value encoded in its attributes, and we can extrude that based on each layer to get a true representation of the building height. We extracted that data from construction drawings, and then we've digitized all of the roof forms using pictometry or, in some cases, other construction drawings. And so you can actually use a Z-enabled feature class for the roofs and encode the Z values into each vertex. And it's a little bit tedious, but it will get you some really high detailed roof forms. And then you can take that and convert it into multi-patch to be consumed in a web scene, or you can visualize all of this on like a paper map or in ArcMap or ArcGIS Pro. So this is a look at kind of one of the first passes of a building in our older 3D map, our 3D web application, where you can see the individual floors are clickable. You get the attribute information, and this is all controlled within the application, so you can show or hide whatever you'd like. You can see the individual roofs, and each feature in here is clickable and stores its own data, and we have one of our campus base maps beneath it. And where we're going from there, this 2D-based data converting into 3D so that we don't have to redo textures or redo the export every time, is something like this. So this is the same building with some additional features. It's still based on, each object is individually clickable. You can see we've changed a little bit of the structure. We still have the floor plates and the roof, but we've added this exterior walls feature class that we have floor to ceiling. It's one object. So, and we're going to get into it a little bit more, that you can actually click on any of these things. You can click on every tree. You can click on every statue. Everything that you put on here has attribute information that you can interact with in our web app. So I'm just going to run through this briefly, each of the layers that I'm talking about. Naveed's going to get into a lot more detail with the actual demonstration. But here you can see the clickable exterior walls. You can turn those off and view the roof, the rooms, and each floor plate. You can turn the roof off and see these are rooms that we've generated from a combination of CAD and GIS methods. Each room is individually clickable as well. So if you have usage information that you want to display, you can do that. These can all be symbolized custom. You turn those off and you get to the second floor plate. that has some additional functionality that Naveed's going to talk about for storing drawings and things like that. Turn that off, get to the ground, and then the ground floor plate again. And then kind of the third section I'm going to talk about is capturing and visualizing some of the stuff that's actually at your campus beyond buildings. So we've explored with two different methods for small and large scale. For something like a piece of public art, we have used a GoPro on a 10-foot pole that we walk in. It's taking photos every half a second. We run that through Pix4D, and it'll generate some outputs that we can then process and through another workflow get into our web scenes. And then on a larger scale, this is one of our new buildings that we just built on campus, and we can do a similar process using drone photography to actually get into visualizing this as well. And this is a multi-patch feature here. So it can also have attributes, it could potentially be edited, and you can work with it just like any other multi-patch feature. So now I'm gonna pass it off to Mari, and she's gonna talk about where we are and how we're using our data.
Okay, so the next section we're going to go through is where we are today with our 3D campus data, and our current uses for it are with planning studies. There's a fly-through animation for capital projects, and then our interactive 3D web map. So kind of like our first foray into using 3D data was with static maps for planning studies. So these three are using the actual building elevations. So this one is a helicopter approach analysis. There was a new helipad at the hospital, and then we also had a new building coming up that was going to be taller than a lot of the buildings in that area, so they wanted to make sure everything would be okay. This map we made to compare building age, color-coded, and then also with the 3D extrusions. And then this is campus development plan. So it includes current buildings and then proposed development. This one's a little different because the 3D extrusion isn't based on the height of the buildings. The extrusion is actually the age of the building, and then the color saturation is the building replacement value. So it was a way to compare those two values of the building. So the next thing we kind of go into is this capital projects fly-through animation. So this is just some background of it. I'm going to talk through it, though, while we actually watch it. So we made this fly-through animation for the Board of Regents to show upcoming capital projects for the campus. We did it with our 3D data and in ArcGIS Pro. A video was then exported, and we used After Effects and Premiere Pro to add in the 3D text and all the title text. There was a bit of hard labor that went into it, so it was definitely a few weeks of stress. But the main campus buildings were extruded based on each floor level, so with their floor and ceiling elevations, and then those Z-enabled roofs. And then the new buildings were kind of more of a more simple extrusion. We also added in trees, which took some data massaging to make it work, but we used the Esri preset for realistic trees to symbolize those. And it was well received by upper administration, so it's set the scene for even more requests of this nature. So Naveed's now gonna walk you through our 3D web map.
So I'm going to skip the slide for the moment and jump directly on to the application demonstration. I'll discuss those points during my demo. So this is the basic view of 3D web mapping application. It consumes a lot of data. So first of all, I'm going to show you the building on which we applied the textures. It's CAD. We can turn off and on the layers. So first I'm going to discuss the layout of the application. On the right, top right corner, we have layers panel, where we can toggle the layers on and off on the map. On the bottom, we have this symbology panel where we can change the building edges to sketch view, solid edges, or if we want to see no edges, then we can transform it. I'm going to show you later in the demonstration. And on the top right, we have a navigation panel for the application where we can pan, zoom, and rotate the application. So if I turn off roofs and walls, we can see rooms and floor plates for the building. So there are 2 floors for this building. If I click on a floor plate, we can get attribute information for that. Let me turn off rooms. And here we have floor plan drawing that is associated with the building. We can click on it and get to the layout plan for this floor.
What program is this on?
It's using Esri JavaScript API. And this is web scene. Yeah. And that's the sculpture in front of the building that James has earlier showed you.
Is this link available to the public?
Yeah, this is publicly available. You can get access to this application through maps.arizona.edu and /UA3D. And this application consumes different kind of data. Like we have 2D feature layers that are being published through ArcGIS server. We also have 3D scene layers that are being published through ArcGIS Pro on ArcGIS Online. And all this data is being referred on this application. And almost all of the features, they are clickable, and they have attributes information associated with them. We have shadows applied to the scene, and they are completely customizable. So JavaScript API, it provides us framework. We can set day and time of the year, and they can be adjusted according to that time and day of the year. So this is the building that is being created through 3D mesh. It's HSIB. Construction fences are also there. We can turn on and off construction fences. So it indicates where construction is going on, and it's limited for the public access.
How often is this updated? Like when you say it's construction, so for example, when construction is done.
So right now, this data is a snapshot of our real life database, and we are working on a framework where we can directly refer it with the live data.
So it's synced together.
Yeah, they are not right now, but in future they can be.
And our 2D maps do have a nightly refresh process, but that's kind of the way we're wanting to move towards with this framework for 3D. It's on an as we can do it basis right now.
So for example, with attributes like fences, things that are not permanent, this is captured on your 2D map and then transferred over to 3D.
Yeah, so there are methods where we can convert 2D data on 3D. Yeah.
Do you have any concerns in a security aspect about having your floor plans available to the public?
Well, I'll just mention really quickly that the one that we put on here for this CATS building is for this demo, and so we don't normally have all of the PDFs linkable. We do have, if you have a U of A NetID logon, then you can get to the PDFs. On a couple of our apps, we have floor plans available, but they're for navigation, wayfinding only. And so sensitive buildings are filtered out. There's not a lot of data. It just tells you where it is and the room type. And so far, we haven't gotten pushback from that. So that's been good. But then certainly for more detailed, like there's a presentation we're doing at 3:45 on our interior floor plans application. And on that one, you have to have a login, and there's a lot more data available, and that's where we're being more cautious about security. So.
Yeah, and we can use this application for testing and data development. Like we added different kind of data sets on the application for testing purpose, and in future we can enhance it. So there are trees layer available. It is also a snapshot of our Arboretum live data. So symbology is applied on Arc Pro, and we adjusted it in ArcGIS Online and then publish it from there as a scene layer, and I'm pulling that scene layer into the web application. We can click on individual tree to get information related to it, like its family, its genus, what's the name of the tree, width and height, etc. At University of Arizona, we have a shuttle routing network. It's called CATRAN. We have CATRAN data also added on the application, and we can have live feed available on this application as well. For example, I can add stops and routes on the map. So this blue dot is showing where our CATRAN for green route exactly is right now, and it's moving as long as we get the updated data. And stops are also added in the application, and they are oriented according to their exact orientation. And you can see the names of the stops labeled on top of them. We also have parking lots available. This layer is also available, and we can also get attribute information for parking lots as well. And I mentioned earlier that we can change the symbology of the building. Like if I want to change from solid edges to sketches, then you can see the symbology of the buildings is changed from sketch, from solid to sketch. And here is no edges. Yeah, so that is all from me.
Great, thank you. Let's see if I can get back to this. Okay. So is it, let's see if we get back to the, sorry. Okay, great, thank you. So I'm going to talk just briefly about some of our future directions. And let's see, I'll just jump into this. And what we want to do is try and leave time for questions. And so some of these slides are in here really just as information that if you go back later and look at this, it gives you info. But I really want to just kind of go through this quickly so we have time to discuss this if there are questions. So this just reviews what we're doing with Multipatch 3D data and 2D data. So some of our 2D data that we have, such as floor plates and roofs, is being converted into Multipatch, and then we're going to create some new 3D Multipatch layers, such as the building exterior walls and other components to give a more realistic view of the buildings. Some of our data that's in 2D will remain in 2D and still be used in the web maps, such as the parking lots that Naveed showed. Some of that data has to get processed into Multipatch as part of the workflow to be in the web app, but it will remain in the source 3D app or database. And that was one of our goals, is that, again, rather than having a data set that we have for planning and a data set that we have separate framework for interior wayfinding and so forth, we've really wanted to try and find one method so all of the data lives in our enterprise geodatabase, and then we can deploy it into different applications without having to duplicate and maintain multiple data sets. We do anticipate integrating with other software where we need to, like the work that was done on the fly-through video using the Adobe products and so forth. We do expect to leverage a lot of BIM data. We've started to receive BIM files, but most people, to be honest, at our institution really don't know what to do with it. It's being used in the construction process and the design process, but beyond that, it's not really being used, and we haven't had enough source info to explore it, but based on things like the direct read into ArcGIS Pro of BIM files, we expect that will be a major source that will feed into this. But again, at this point, we're not looking broadly at all things, everything 3D. It's really about how do we leverage our resources we have and build on that. So, yeah. Well, we have mapped some of our utilities in the GIS. We haven't deployed it in a 3D setting yet, and we do have, from the trees that were shown, for example, are kind of an asset management component, and we've integrated with facilities management on that. So that data, there's an app we have that when a work order is put in on a tree, it shows up in the app and vice versa. And so there are some examples where we're moving in that direction. So, and in terms of some future use cases and applications, we see a lot of use for our campus master plan process that's just starting right now. There's a lot of interest in marketing, tour, and VR, AR applications. We're expecting to rebuild our Campus 360 sort of all-purpose web map as a fully 3D application. And by the way, I'll mention that most of our maps do not require any authentication, authorization. So you can go to maps.arizona.edu and you can get a list to a lot of those, including Campus 360 if you want to take a look at it. And then other spin-off integrations like putting room and interior information in 3D, indoor wayfinding and so forth are some of the other applications that we're imagining that we'll build on. And so now that we've pulled back the curtain on the wizard, we'd like to take questions and just say thank you. Our contact info is here if you want to get in touch with us later. Yeah. Well, one aspect we've talked about is using imagery as part of our base map. And so that's one element. And then the example of the building, I think James mentioned, and then it was in the web app, the HSIB building is actually that type of information. One of the things that we were really wanting to do, so there's one path where you can do an entire campus that way, which is sort of like Google Earth, which has that look to it. And then so far as we know, there's not really like that doesn't intersect with the full GIS path. But what we've done though is found a way by the conversion of one of those models into a multi-patch to integrate it with the web map. So we expect to kind of hybridize those systems. But moving forward, we expect that most of our sort of photorealistic buildings will be done the way that was demonstrated using multi-patch. Yeah.
You said you're kind of working on copies of the data, right? How long does it take to process like a building or what? Like if you're moving stuff from one place to another, like what's your processing time? How long does it take to get the layout that of the building?
Well, I'll just say that the process is that it's not real. It's a copy, but it's not like a separate copy that's kept unto itself. So it all starts from the same source data, much like our regular web map flow goes from the source data and it's nightly copied to a file geodatabase, which is what the maps consume. And so, but in terms of the timing, I think Naveed might be best just to give a general idea of from the database to the web app, what that involves and the general amount of time.
So we have enterprise geodatabase in place, which is in SQL Server, and so that's the basic data where we perform editing and live edits are being performed on the data. And we have nightly scripts in place that convert that data into file geodatabase. And that's the basic data which all our web mapping applications consume. So it gets updated pretty much every night.
In terms of the 3D specifically, I think might have been the question, like to create the 3D, UA 3D web map, the time going from the geodatabase to what's shown in the web app, the processing time?
So we created multi-patch data from the file geodatabase we have already available, and it doesn't take too long for conversion. It's a geoprocessing tool that we run on the data to convert it into multi-patch. And once it merely takes, I guess, 5 minutes or 10 minutes. And once it converted into multi-patch, then we create like if so there is a feature limitation on the data. So if we have number of feature less than 2000, then we can directly publish the data on ArcGIS Online in scene layer. And if we have a number of feature exceed 2000, then we have to convert the data into scene layer package. And it's also a geoprocessing tool that takes less than a minute or two. And then we upload the scene layer package on ArcGIS Online that we can consume in web mapping application. Yeah.
I think we're about done.
Unfortunately, our time has expired. I'd like to thank Grant and